Good afternoon, everyone, and welcome to our First Friday webinar series. This is Ariana. I'm going to be running the webinar today because Suzanne's out of the office. So you all should have received an email with the link to the handouts and the quiz that are on our website. If you didn't, or if you can't find them, you can email me at info@illinoisengineer.com and I can get you squared away. And that goes for any of the questions that you may have regarding the webinar. If you have questions for the presenter during the presentation, you can type them in the question box and we'll answer them at the end. So without further ado, I'll turn things over to Alan.
Great, thank you. Thank you everybody for taking time during your lunch break here to listen about a great project that's been going on in Kenya through Engineers Without Borders. This is basically termed Wema Children's Center Well Repair Program, but there has been a lot that's been going on since we've traveled there. So it is a multi-collaborative initiative taking place in beautiful Western Kenya. Let's see here. The slide is not moving. There we go. Okay, so a little bit about me real quick. I am Alan Phelps. I am an infrastructure engineer at Baxter & Woodman. I've been here for coming up on 4 years now. And during my time here, I've been involved in the EWOB Chicagoland Professional chapter for about 3 years. Maybe it's a little longer than that now. I am the lead for this program, and I was previously university chair. I guess I have given this presentation a few times and things keep changing. So I was previously university chair. All right, so here's an idea of everybody that was involved in the success of this project. Wema Children's Center is our client, and a little bit of their background is it is run by Stephen and Teresa, Stephen Juma and Teresa Wati. They have actually been running a school called Highway Academy, which is the same school here. And they ran this started this about, I don't know, 15 years ago. And during that time, maybe about, I believe 10 years ago, they saw an AIDS epidemic that was occurring in their community, which was Bukembe village in Kenya. And they heard about the Millennium Developing Goals sent out by the United Nations, and they took it upon themselves to make a difference in their community, and they literally took in what was about 200 kids back then and is now about 500 kids right now. All were orphaned and because of the AIDS epidemic and election violence. So they took them into their school and started running the Wema Children's Center aspect of the Highway Academy. And sometime after the beginning of Wema Children's Center, started Wema Children Incorporated, and they are our US-based nonprofit support for this school. And they are the ones that we have been working with most closely during this process. So the problem that was in Bukembe Village at Highway Academy and Wema Children's Center is they constructed a deep water well about 2014, and about 5 months after that, after commissioning, it became contaminated. They worked with a contractor, Living Water International, kind of a big name. I suppose you may or may not have heard of them, but they are a nonprofit based out of Houston, and they have a lot of international presence, especially in Kenya. And once the well became contaminated, they decommissioned the well, and they went back to old means of water collection, which was an old backup well that they had at another part of the school. And they also resorted to collecting rainwater in buckets. Once the well was contaminated, about 50 orphans and students got typhoid from the well because of what you can see in the picture here. It was contaminated with high turbidity and pathogens, obviously. So they decided to keep the well and pump and wanted to have a filter to be able to treat the water. Give you a little bit background where this is taking place. If you look all the way on the left here, you'll see the city of Kisumu in Western Kenya. And as we get closer, we zoom into Bukembe Market. And as we get even closer, here is the main site for the school. Those two long buildings you see near the top, those are the actual school buildings. The one with the blue roof is Stephen and Teresa's house and their main place of operation for keeping the school running. And if you look just a bit south and to the west of that, you'll see another tin roof, and on the northern end of that, you'll see kind of like this black speck, black circle, and that is a holding tank to where the well was supplying. So this began through Engineers Without Borders, I would say, 4 years ago now, maybe 3.5. And I went to Honduras to help out with a different nonprofit to help build a series of sanitation facilities at people's homes. And while I was there, I actually met a few people. One of them was a student at Arizona State, and he learned that I was just starting my career, and I was about 6 months into it, and he learned that I was becoming a practicing engineer and that I specialized in water and sanitation. And after the trip, he got me in contact with his friend, Erica, who was the medical director for Weymouth Children's Center. And he had her talk to me about this problem that they were having at Weymouth Children's Center about a contaminated well. And I talked to her for a while, and for a little while, it was just me and her talking. I never thought that I would ever go to Kenya to help address this problem. I thought I was just going to be behind my laptop for a couple months gathering information and making a recommendation on what filter or other means of treatment was necessary. That led to a series of more and more emails, more information, more conflicting information coming in. And at that point, I was thinking to myself, well, this is starting to get a little complicated. And then before I knew it, I got another email from Erica, and she said, she gave me a website, a supplier's website in Kenya, and it was Davison Shirtliff. And she said, we were planning on buying a filter from this company. Just tell us what you recommend and we'll buy it. And I was like, okay, I need a little help here. And that's when I started to recruit other professionals' opinions. And eventually it led to taking it through Engineers Without Borders and beginning a project. So after that, it was all about building a partnership. I put the project through Engineers Without Borders, more specialized type of program, the way they address problems, and that is known as Engineering Service Corps. And that the Service Corps concentrates mostly on one specific issue, and getting the job done as quickly as possible. If you know anything about Engineers Without Borders, the biggest hurdle is there's a lot of there are a lot of bureaucracy and processes that you have to get through in order to be approved for travel, approve your design, and all these things. And this Service Corps program allowed us to kind of evaluate what was needed, what wasn't, and help us get on the ground faster, especially with a project like this that seemed quite urgent. So the water supply at WEMA consists of what you see here in the picture on the top right is known as the water kiosk. And that is, you see, if you can see near that window, the bottom of that window are 3 taps. And a couple pipes over to the right. The pipe, there are 2 of them that go parallel. If you look closely, one of them goes straight from the ground up to the tank, and then another one is fixed at the bottom and travels right back down the same path. And that's kind of how the simple system was configured during construction. And now keep in mind, this was all existing when we got there. We were not part of this construction to begin with. So with the existing system, it supplies, and this is what we were all told at the time, before we ever traveled, was it was a deep water well that supplied 500 school children. Actually, I take that back. That's all we were told. It supplies 500 school children. We later found out a few other things like connections to nearby homes, and there were people that came along the road with buckets, as you see in the other picture here, filling up the water. So essentially what the system was, it was a well pump, a submersible pump that was inside the borehole, and it would pump up to the tank, and from the tank it would go to distribution. And the well was about 50 meters deep, is the reports that we got. Here's a little bit more detailed view of what the water system looked like after Living Water constructed it. And the yellow outlines are the outlines of the actual property that is Highway Academy and WEMA Children's Center. And it extends a little bit further to the south there. I'm not sure how far though, but the whole area is really not that large. And I'm not sure if you can see very well of the text, but the important parts are the borehole is located near the bottom of the screen there. It's highlighted in teal. And then there's a pipe that goes over to the water kiosk. And then, as I mentioned before, it distributes after that. And it distributes out to the north there toward that end of the school where there is a boys' wash and a girls' wash. And they have connections inside the school buildings, which we did not know. And there's a connection to the director's house as well. So that's the information that we were working with at the time. Here's a on-the-ground look at things. This was a superimposed set of pictures here from Teresa. And this gave us a good impression of what kind of technologies they had available to us. So she was able to mark this all up for us and give us an idea that, oh, they must have computers there. And, excuse me. And you can see here, as it's labeled, the well pump sits in this tin box. And we never knew what the wellhead looked like ever until we got there. And when we got there, it was a kind of interesting situation of trying to find the keys for it. So while that wasn't completely essential to know that information, we did have some good information here, and I'll kind of walk you through that in a little moment. So the pipes the pipes go through the ground, and they go north and south of the road here. Now that I've been there, this is going north, I can tell. And this is the other end of the system at the, this is at the boys' wash. And this was inside somebody's home. When I got this picture, I was kind of curious as to where this was. Sometimes getting straight answers, definitive answers, was a little challenging, but we kind of went with the idea of, okay, you know, there are probably connections outside of the drawing that we were looking at before. So there was a need for clean water, of course, and here are some of the pictures along the way that were kind of proof of, you know, the problem that existed there. You'll see a text message here, the biggest picture, and you can kind of read that for yourself. That was from Alex Brannon. He is the president of WEMA Children Incorporated, and he just happened to be there at the time during our design, which helped out a lot. And he sent that text to Erica, the person I was formerly speaking to about this, and it became apparent that there is a problem whenever the pump goes out and due to power loss, and then when the pump comes back on, then that is when they see the biggest problems with the water quality. So after a year, the water became contaminated with silts and turbidity and pathogens. Erica herself got typhoid from the well, along with 50 other kids over there. And it was actually so bad for her that she had to be medevaced out. And what we knew at the time is that they resorted back to rainwater collection, and that illness was still present. The contractor, while we did not really deal with any of this, it's not really not our thing to get involved with. We've been told that the contractor has claimed no liability, that they claim that there's no problem with the well and they cannot come back and fix it. So that is why we got involved, and at least to my confidence back in them involved that they were able to have one of their staff members who was there helping drill the well. He was able to be in contact with me and answer all the technical questions that I had. And he did a very nice job with it, and he was always not over a couple days of no email reply. So that really helped. And then we found out that the well was actually only drilled a quarter of the way. It was supposed to be 200 meters that we found out later, but it was only drilled to 50 meters. And all this information, we just, as we get the information, we're just kind of thinking to ourselves like, oh, you know, either some things check out, some things don't. Why did they do this? Why did they do that? And some of those answers we just never quite got an answer for, like that one. We still don't know to this day what exactly stopped their construction. And even Stephen, when we talked to him, we couldn't get quite that answer from him either. So while collecting all this information, we're starting the design process. And this all occurred, all this design occurred April last year to about November last year. Yeah. And it all begins with research and assessment. And we are gathering background information from WEMA Children's Center, as I mentioned before. Something that was really nice is, since they are U.S. nonprofit and can support this school in many ways, they actually have their own volunteer program that they've been operating for the last 5 years, I think. And this involves sending a number of students from different universities that they were affiliated with, that they had networks in. Students would go there to do all kinds of things. They would go there to help with development, with whatever that entails. It could be development of they need a new latrine. Where's a good place to put it? Or they have a lot of teachers, students that go there to help teach. They are a school. And there was a student that went over there to do a lot of upgrades to their computers, bring over donated computers. So they actually have a lot of those types of resources there. And then contacting Living Water International was a big thing. I worked with them for a long time during the design process, and I'm in some ways still working with them now to get information that's necessary. Do know that this is not the typical approach to EWB projects. We never visited there except that one time to go and build. Usually, EWB projects would require an assessment. You would go over there and do your survey, talk to the community, understand. And since this was Engineering Service Corps, we were somehow able to get past that. But at the same time, as uncertain as I was thinking, oh, maybe we should go there for something to find out more. I kept finding out more through emails, through volunteers that went there, and it started becoming to the point where I'm thinking, well, if we go there, like we can confirm things, but that can take a short amount of time, or it could take a while, depending. But I just kept thinking, we have a ton of information now. Let's start the design. You know, if there's something that is crazy that just it would be a deal breaker in construction, then yeah, we would go there to do an assessment. But it never got to that point. So we just kept going forward with the design and kept moving along with it. So then begin some challenges. And this can happen in any project, but I feel like I've never seen as many challenges as I did with this one. There was conflicting technical information, and here's some of the information over here to your right. The picture all the way in the back is part of a commissioning document that was given to us by Alex Brannon of Wemmachiller Incorporated, who got it from Living Water. It was their report. And I'm looking at the report. You probably can't really see it in this picture, but in the top there's some specifications on what pipe was installed, the size, what type of pump, and that information was conflicting based on the emails that I was getting from Living Water. They would tell me something, I look at that, and I'm just like, no, it doesn't say that. And then I tell him that, and then he says, oh, it must be an error with the commissioning document. And I'm like, okay. So this kind of required us to do some backwards engineering based on the measurements that we had and see, you know, how much head loss are you getting through the pump is if you do 35 gallons per minute, which is what was reported, you know, does the tank fill in as much time as we've been told? And a lot of that backwards engineering actually helped with clarifying a lot of information. And for the most part, it seemed that whatever error there was in the commissioning document was actually an error, which was nice to be able to confirm, especially without having done an assessment. So yes, we've resorted to our best engineering judgment, and there were potential errors in information. Like if you look at the middle picture there in between the other two, that was a drawing that I got of the site plan from Living Water, and all that red is actually my markups, my questions that I had. And there were a lot of things that kind of didn't make sense to me, or things I needed to confirm. And it was this constant back and forth of sending questions, getting answers back, and confirming, and backwards engineering. And as cumbersome as that was, we were making progress. Next slide. Okay. And here's an even closer picture of it. And there were a lot of decisions that we had to make on engineering judgment with all the conflicting technical information. We as I mentioned, we experimented with hydraulics, and we did decide that we are going to work with 1.5-inch diameter pipes to design the treatment. And we didn't worry too much about the existing line that was after the kiosk, after the tank, because we weren't really working with that. And the water is going to be going into the tank, and we didn't worry too much about what would happen afterward because it wouldn't necessarily be affected. And whatever water was going to the tank to begin with would come back down into the distribution system. What we were really worried with was from the borehole to the top of the tank, because that is where we would be implementing a design. All right, so now we're really getting into design, and this is where this starts getting into the whole Engineers Without Borders type of model. And what is really important for a developing community is that you have community understanding. You know, we can engineer something crazy that ends up working, but you know, they need to be able to operate and maintain that. They need to understand how it works, which valves to close, what to keep open, what does what. And as we kept designing, we tried to keep this in mind as much as possible. And using local materials is a big part of the model. And we were thinking, well, what can we make these filters out of? What is a material that has good enough depth, that is good enough diameter? Do we need more of these to be able to keep up with the demands? And we thought of the idea of using 55-gallon plastic drums to be able to fill those with sand and other media necessary, and fit pipes through it, and have that act as our treatment system. And we were designing it to be a pressurized treatment system because we needed the water to be filtered and treated before it ever went to the tank. And we had to fight with the accuracy of design as well. With Engineers Without Borders, you get people from all kinds of backgrounds. We have electrical engineers, we have software engineers, we have civil engineers, mechanical. So a lot of the time, things become a learning experience. And we needed to find the right people to check calculations and kind of have their 2 cents on alternative solutions and see if they think what we were doing is feasible and a good idea. So this is what we were dealing with before I show you what we came up with. So if you can see here, I kind of drew in some superimpositions here. If you can see to the right, I have a well drawn with a submersible pump. Kind of looks like it, right? Here's what happens. The water goes up and goes through this pipe that comes out here where you kind of see that that cutout in the concrete. And it goes over to this way toward the tank, then up the tank and into the tank. Then from there, it comes back down and then goes out the road. On the far end there, we were told that it was plugged, that after Living Water constructed the system, it was plugged for any future expansion. And then the line comes out this way, as you saw in the aerial. So with our design, we're going to have the water continue out naturally as it does now, but we're planning on putting 3 55-gallon drums filled with sand and other granular material, have it filter through there, and then go right back out a pipe that goes right back up into the tank, and do the same thing before. So this is what we came up with. here's a Google SketchUp version 3D of our design, and this was what the inside of the kiosk looked like. There was this existing beam inside that we had for support that we kind of had to work around. And essentially we developed a design that was 3 filters in parallel. And it would go through this chlorinator assembly here at the end. So you're getting filtration and chlorination, which we had to deal with turbidity and pathogens. So that made the most sense to us, especially in the amount of room that we had available. So this actually started becoming a little complicated. We wanted to make everything manual. You know, if there's ever a problem with these filters, they can bypass it. If there's ever so much sediment coming out of the tank and we don't want the filters to get clogged up so much within 2 minutes, and then they have to clean it out again real quick, that we gave them this high turbidity discharge field okay, that's necessary. High turbidity discharge pipe that can blow it out into the grass whenever those events would happen. And it was, we took this to several people and they all said, you know, this looks like a great design, everything's considered. And then things would start getting a little bit more complicated because we're like, okay, we have all these valves. What kind of valve are we going to use? Is it going to fit into this pipe? How do we fit it into the pipe? How do we maintain these filters? How's O&M going to work? So after all the conceptual design is done, that's what we were starting to work with. And that feeds into the community understanding aspect. We had to make a design that was simple enough, but still solved the problem. And as we started making a design that still solved the problem, it was getting a little complicated. And the O&M would be challenging too. If you're familiar with BioSand filters that have been implemented in projects before, EWB projects and projects by other not-for-profit organizations, BioSand filters require kind of a scoop off the top layer and clean out the sand, put it back in, sort of maintenance. And that was what we were planning here. So now we needed drums that had a removable top, or something just as easy. And as we kept adding, as we kept fixing certain things that would come to mind, like, oh, what if it's too much pressure coming out of the well? Are they going to blow these filters? So we had the idea of, okay, we'll put a globe valve or a gate valve on the main line and kind of reduce the pressure that way. So as we kept thinking this, we kept adding more quote unquote solutions. And the challenges included tricky hydraulics because the pump was oversized, as we learned later on. It was oversized to be able to compensate for future population growth. And it was nice because it did give us a good amount of head to work with. But this is going through 3 filters, it's going through a lot more pipe, it's going through a chlorinator, it's got all kinds of these head losses occurring now that weren't there before. So as we think of new and better ways, then now we're running into the problem of, oh, well, the water's not going to get to the tank anymore. And we kept going through different alternate designs in our mind, and it just became really tricky. So I kept getting second opinions. And then once all that is figured out, we can't, sometimes materials are not always available. And the only way we would know what's available there is I would email Teresa, ask her if she can go to the hardware store, send somebody there and see what's available. And then when I get an email back, it's like only half my questions were answered, and it would take another week for them to be able to go back and take a look. So things started getting a little complicated, and I started consulting other chapters who had done a project nearby, which was actually EWB Indianapolis. And they were helpful, but their project was a lot less mechanical, so they couldn't answer all of our questions. And at the very end of it all, this was February, I believe, there was somebody in the chapter that had access to a lot of things at his workplace, including 55-gallon plastic drums, and he fitted with an air hose, and he said that it was deforming at 6 psi, and we needed about a pressure to be able to hold about 18 psi. So it's a crisis. Our design was approved in January. It was approved by Engineering Service Corps, and I thought, you know, this, I kept getting told that nobody had ever experienced like a pressurized filter. It was always like a gravity fed filter, but we needed to keep up the supply to the demand of people that were using it. So we couldn't go that direction. And the feedback I got was, oh, just make sure you look into this, look into a backwash and how that would work. And then it got approved. So by the time it was tested in January, we found out very bad timing that it didn't seem like it was going to work. And now that the EWB model of using locally sourced materials would not work in this case, so now what would we do? Well, now that I've kind of been around the block a little bit more, I learned how common contractors in EWB projects actually tend to be, especially if they are a little bit more of a special case scenario like this. And this is the company, Davison Shirtlift, that I was told about from Erica a year back, and who said, we're going to buy a filter from these people. What do you recommend? I did not know that, well, for one thing, I did not know that they were going to be as cost effective. I thought this thing was going to cost above our budget like crazy, which is why we use local materials. And they came back with a price to me that was only $1,000 above what we had estimated. And we had that in the bank. And I'm just like, why haven't we looked at this before? And then I thought to myself, like, oh, I haven't looked at this before because they're operating pressures. I took the slide out earlier, but if you can see on the bottom right there, the picture that's back there, it's kind of a breakdown of the technical specs of their filters. And they all have an operating pressure of 7 bar. And 7 bar is about 100 PSI. And I'm thinking, there's no way we can supply 100 PSI. Like, how's this thing going to work? So that's why I never revisited it. And then I sent them an email saying, you know, is this going to work? This, I don't think we can do this. And they emailed me back saying, oh, well, actually, that is operating pressure for the maximum. That's the maximum that a system can operate. And they're like, so a low pressure system actually works very well. And I'm just sitting there 3 weeks before we leave at a coffee shop, and I'm like, yes, oh God, this is great. So once that problem was done, we had to kind of redo the hydraulics because now we went from 3 filters to 1. And how is that going? Is the water going to get up there? We can't afford 2 filters. And we actually did calculate that it was going to make it. So that was fortunate. We were given a straight head loss number, and then we compared that to our own calculations, and they were both checking out. So that was great. But now funding, while we had the money, it was just not available to use yet because it had not gone through EWB's process of being able to get approval. And I'm just like, why is this taking so long? We got to, I had to send another cash advance because I had only budgeted for the local materials. Now I need another $1,000. And there were some people in the chapter that were got uncomfortable with the idea of having 2 cash advances out at once, and I'm just thinking, okay, I leave in a week. I haven't even packed my bags. I have to coordinate the rest of the team. I can't deal with this money issue right now. So I went directly to the top. I knew Kathy Leslie, the executive director of EWB from previous conferences, and I called her directly, and God bless her, she got our amount approved, and we were able to not worry about that anymore. Oh, I guess I didn't take the slide out. Well, if you are interested, just take a look to the right there. You see 7-bar operating pressure. Davison Shirtlift, Google them if you're interested in looking at more. So we're finally on site. And to my not so surprise, we find out a lot more than we've known. And this includes this pit over here to the left. And that is a pit that is dug to install a septic tank. A big septic tank in front of the new girls' dorm, which was right across the street from this water kiosk. First red flag in our minds is like, is this far enough? Like, is this going to be another problem? Because it's part of our speculations as to where this red sediment was coming from is where was it coming from? We had suspicions, yeah, I mean, obviously it's coming from the well, right? But could it be coming from latrines that are kind of in the pipeline path? Could some of that contamination come from there? I had no doubt in my mind that it was the turbidity was coming from the well because it's such high quantities, and it made me hard to believe that it would be coming from a little crack in the pipe, especially when the well would turn off, and then when it comes back on, then it's highly contaminated. So we found out that it was about, it wasn't that far. I mean, it was far enough. It was about 130 feet, so we didn't worry about that anymore. And then we found other sources of water, like this spring, that was down the community a bit. It's kind of out of their property, but it's a good idea to know where all other alternate sources of water are. And I see that time's kind of eating up here on me, so I'll try to go a little faster. So we find out other things. Finally, over here on the right, we see that the wellhead is opened up, and this is what it looks like. Pretty simple, didn't change anything. But we did find out that that was 2-inch pipe, and that was a little different than the 1.5 inch that we were dealing with before. And then in the middle picture there, I'm holding a piece of pipe that was on the ground, and Stephen tells me that that is a 1-inch pipe, and that's what is used in all distribution. Again, not what I was told. I was told 1.5 inches, but we weren't too worried about that because that's not what we were working with. So we had project meetings and site assessments. We didn't have the contractor come until a couple of days after we got there because we wanted to make sure everything was good as far as what we've been assuming all this time. And while most things were, that was a good thing to be able to confirm a lot of things right away. So we met Stephen. He's the guy in the Hawaiian shirt there. He's one of the directors that runs the place. And we do this whole walk through the water system with him, and there I am off to the right with a student who had just graduated from Highway Academy, just kind of talking to him about his experiences and things like that. Field assessments continue because we are now having kind of this issue with the contractor. They come on site and we go through the whole assessment. We tell them what's going on, and now we're starting to hear them say that they're not able to come on site the day that they said they were, and things are starting to get a little odd. So we do more field assessments so that we have all that information for future work. You can see we're measuring a lot, taking pressures. and mapping things out. But something that was alarming was this tank assessment. The water in the tank would overflow, and then the guard would come over and turn the pump off, and he would do that all day long. So we heard that there was this float valve that was inside the tank, and that they wanted it reconnected. So we go up there and we look at the tank, and we see the top here at the bottom. It's dented inward, so the water just sits there, and then algae grows. So we determined that was another source of contamination that we were not aware of before. And when we looked into the tank, it kind of became obvious that you notice that the entire thing is lined with this red sediment. It's definitely been a problem. And so essentially one of our new projects right now is to replace this tank. And then more things we learned. We just discovered more water users. Here's a picture of the new girls' dorm that they had under construction. Me standing next to the pit there that you saw earlier. But they use the water for irrigation as well. They use it for 12 homes that we found out when we walked the path, that they're connected to 12 homes that probably have like 3 to 4 people living in them. And then people walking along the way. I've seen kids filling up their buckets all day long. This well, this little 6-inch diameter well that goes 50 meters down is getting more stress than I was ever aware of. And I was really shocked to see that it was keeping up. And then there was a market school over here. The kids over there in the upper left, that was actually a school owned by WEMA that was in a different location. It was more in the downtown market area. And this is where all the little ones go to school, and they have a water source right now from the government, but one of the things that WEMA wants to do is take them off that and connect them to the well. And then the other 2 pictures are pictures of a bakery that they're planning on getting going pretty soon here now, and they need to connect water supply to that. So here we have a bakery added on, so that's even more water. And then finding materials was a little interesting. There were hardware stores in Bukembe, but we found a lot of our things that we needed over in Bungoma, which is the much bigger town off to the west, about 20 minutes. All right, so big deal here, contracting and supply issues. The biggest deal here on site was the contractor seemed pretty unreliable. We were kind of warned this at first by One Acre Fund, who's a good friend of WEMA Children's Center, who operated out of Bungoma. And the problem was the contractor would not show up when they said they would, and it would happen for days and days. And then they actually came back with this, if you look at the lower left, there are pipes on top of that car. They came back from the hardware store, and this was Sunday. And they were like, oh, yeah, we're ready to do construction. We got Class D pipes, and we're ready to go. And in that picture, you can see me measuring the pipes, and I'm just like, all right, well, it's about 2 inches is what we were planning on. And then I look at the pipe, and near the bell of the pipe, there's this label, and it says Class C. I'm just like, I'm thinking to myself, like, yeah, I mean, it is a little thin. I don't know how thick the existing pipe is because we didn't cut that out yet, but I'm like, it does feel a little thin, like I can kind of squish it. And then it says 150 PSI. I'm like, well, that's water main, I don't know. And then I just go up to this guy, and I'm just like, you said Class D, right? And he's like, yep, Class D. And then I said, then why does it say Class C? And he goes over to his car, pulls out his receipt, and then he looks at his receipt, and then his arms fall down to his sides, and he's like, it's not Class D. I'm just like, yeah, it's not. So what's going on now? And then he said that they can't do the work today because it's Sunday, the store just closed. He said, you have to understand, this wasn't us, this was the hardware store. And I'm like, it's only Sunday, it's whatever. We leave Thursday, and as long as you're back by tomorrow, the store's open, go ahead and do that. And at this point, I was kind of mad because they had just shown up 3 days after they said that they would, and now no work is getting done. So that's why we did all those assessments before. But something I do want to point out is this cutout of the existing pipe. You can kind of see the inside. So the tank is filled with it. The pipe is lined with it. Red sediment film. We believe the well indeed was the source. Main source anyway, I would think. So after all this fiasco, the A team finally arrives. They say that their contractor had, quote unquote, gone rogue on them, and they need to replace the team because the job needs to get done. And I'm like, yes, it does. And I'm really mad at this point. And so they finally come in, and these guys knew what they were doing. They got the job done. We made them work till like 2 a.m. And they got it done before we left. So this is what installation looked like, completely different from our design. We even outfitted the front so that it can kind of operate in different ways. You can bypass the system completely, or you can have a tank blowout, washout. So we put the bypass on the outside now based on redesigns. So this filter was actually an amazing thing because it was so capable. That one white valve there you can see in the picture was so capable of doing everything, bypassing, backwashing. Backwashing was a huge issue. I did not know how we were going to do that with manual filters. And now this thing was able to do it all. We went from like 20 valves down to 7. It was the craziest redesign in the field I've ever seen. So we finished just in time, but this happened. Now the rains there are insane. It was so loud that we couldn't even continue teaching the kids about water. We just had to wait till the big part of it passed. And unfortunately, it knocked out all the power, and we had to leave the next morning. We thought it was going to come back online, but it didn't. And we had to leave without seeing the commissioning done and do any testing of our own. So that's something that we worked on a lot this summer with volunteers that went there, worked with Stephen and Teresa over email, telling them how to do things. And we were able to get that done by now. So here's just a quick look at the before and after. Here's the design to the left and what happened here to the right. Huge difference, but the same result. Same mission is done. It's kind of amazing. Try to burn through these pretty quick. So here's just a nice couple pictures of all the kids that we were there to help. We did an education day at the end, taught like 3 classes. And I just want to point out, it's not just work. You do have fun with this organization and on these trips, and having that kind of fun is really up to you. We took a break and played volleyball with the kids. You know, I had no idea that volleyball was a big thing in this area of Kenya. And thankfully, I love volleyball compared to soccer. I was really dreading, I gotta play soccer, but now I'm like, are we gonna play volleyball again? So some follow-up since implementation. They started training without me telling them to, training a couple people on how to operate and maintain the system. And these ones in red are kind of like what happened since I gave this talk at the conference, ISP conference in July. So we back in September, we called them asking about things, and they said that they've been getting no waterborne illnesses from the well. They said that nobody's coming up to them with sicknesses like they used to. And then since then, there's been a new full service office in Bungoma that was opened up. And there was concern at the conference, somebody saying that they're worried about, the O&M of this. But at this point, this full service office has already been in contact with Stephen and Teresa, and they've already ordered new chlorine tablets and have everything set up for O&M. So that's amazing. And then chlorine testing has been showing pretty good residuals at 0.5 and 0.3 in a couple different locations, milligrams per liter of chlorine. A few pictures from a volunteer that went there that helped us out, get out this information. It's chlorine test. And then some new projects that we are working on starting up is we did this water model, and the water model does suggest that extra pump head has been eaten up by the head loss induced by the filter. So now we're looking at other sources of water as part of new projects, and it's our goal to be working in this community for a couple of years here to come and see all this through. And just some acknowledgments here that I did not have before. Feel kind of bad about that, but there was definitely a lot of people involved in making this happen. And all of their help has been amazing. Anyone from being a project mentor to somebody who worked on design with me, to people who donated, to coworkers who have given me their second opinions, and to the WEMA team especially. They've been so helpful and so engaged with this project and really want all these improvements. Whew. All right, well, sorry I'm kind of pushing time here, but here is my contact information if you have any more questions or if you want to ask them now. Or you can visit EWB USA and WEMAchildren.org for more information.
All right, thanks, Alan. So like he said, if you guys have any questions, feel free to type them in now and we can give you some time to do that. And if you don't, you can always email him. So we'll wait a little bit to see if you guys have any questions that want to be answered right now. Okay, first question. Didn't the algae in the bottom of the tank get washed away?
Yeah, we had one of our team members go up there to kind of fix the situation. We nailed down the lid and screened the hole. So the water now flows outside the hole instead of the top of the tank. And while he was up there, he scooped out all the water and cleaned up the top as best as he could.
All right, and the second one, did they replace the storage tank?
They did not yet. That is something that they want us to help them with. And we're going to, as we continue to work here, that is the next one of the next priorities.
Okay. All right, so if you guys have any other questions, feel free to email Alan. I want to thank everyone for attending. Have a good weekend, and keep an eye on your inbox for our First Friday announcement for December, about halfway through this month. Thanks, guys. Take care.
Thanks for attending, everybody.